So in our last clip, we learned about the basics of combining like terms, and we're going to look a little bit more at combining like terms, but we have another tool to add to our tool belt here. We've learned about distributive property already earlier this year. We're now going to look at it with algebraic expressions. So when we look at this first example, where it says 4 times the sum of 3t plus 5, we need to look at it and say, well, if you remember back to our area models we did earlier this year, we talked about you can set it up like this. 4 times 3t plus 5. So we look at something like that. We have to know how to do 4 times 3t because that's the first part of this. So think about this. If I have 3t, and I'm going to do it 4 times, then what I really have there is 12t. So notice what I'm doing. I'm multiplying 4 times the coefficient. So when you have a constant times a coefficient and a variable together, you can just multiply the constant by the coefficient, and then the variable and exponent are going to stay the same. Those are not going to change at all. So I get 12t plus, don't forget, I also need to do the 4 times 5, which is going to give me 20. So 12t plus 20. Another way to look at that is I'm doing 3t plus 5, 3t plus 5, 3t plus 5, and another 3t plus 5. When I put that all together, I have 12 t's plus 20. So you can look at it that way. And then remember, you can also look at it and say, we talked about this, once you understand those and sort of where the concept's coming from, 4 times 3t is 12t, 4 times 5 is 20, and don't forget to bring your addition symbol down. So that's a pretty simple example with distributive property. If we look at another one, this one is still has some distributive property because we have something outside the parentheses, times an addition problem. So we still need to use the distributive property, but there's another term there at the end. So we need to go ahead and use our distributive property, 3 times 4y plus 6, and we can draw a picture for that just like we did for the last one, where we use an area model. So 3 times 4y plus 6. 3 times 4y is 12y, and 3 times 6 is 18, and we keep the addition symbol. We can also look at that as doing 4y plus 6, 4y plus 6, 4y plus 6, and we're putting that all together. We've done the 4y plus 6 1, 2, 3 times. So 6, 6, and 6 makes 18. 4y, 4y, and 4y makes 12y. And again, these are all addition. We keep the addition symbol. So since those are all addition. So we can also come over and just the shortcut is to say 3 times 4y. Remember, do the 3 times the coefficient, so that gives us 12y plus 3 times 6 is 18. And again, it's addition because we're keeping the addition symbol. Plus 8y. Now this looks like problems we already know how to do. So we have 12y plus 8y plus 18. The 12y and the 8y can combine to make 20y, and plus 18. The 18 can't combine with anything because it has no terms like it. Let's look at 2 more examples. So 2 times the sum of 3y and 4 minus 3. So I can still do 2 times 3y is 6y. 2 times 4 is 8. If you need to do the area model or you need to write 3y plus 4 twice and show how you add it to be sure that that's right, go ahead and do that. If you don't, that's okay too. And then we still need to copy down the minus 3. When we look at this and look for like terms, there's nothing like the 6y, so the 6y stays. It's its own term. There's no other terms that are like it. And then I have plus 8 minus 3. If I have 8 and then I subtract 3, I still have 5. So this is addition because I still have 5. The only way it would be subtraction, because I get that question a lot, and I really haven't given you an example of that. The only way it would be like that is if this had been 6y minus 8 plus 3, we would have kept the 6y, but then with a minus 8 plus 3, if I need to take away 8 and then I have 3, I really can only take away 3. I still need to take away 5 more. So that would be a minus 5. So if I have 3, I need to take away 8. I can take away 3 of them, and I still need to take away 5 of them. So that's when it would be a subtraction. When you don't have enough. Think of addition as I have. When I don't have enough to take away all of what I need to take away. I need to take away 8. I only have 3. So I still need to take away 5 more. All right. And that gets more into adding and subtracting integers, which we haven't done yet, but that gives you some of the kind of basic idea there. All right, our last example here that we're going to do together, I can do 7 times 3y, which is 21y, plus 7 times 5k, which is 35k, and then I have minus 14y plus 12. So I can combine 21y minus 4y, or 14y rather, excuse me, and then plus 35k, plus 12. And so when we look there at our like terms, we're going to end up with 21y minus 14y leaves us 7y. And then I can't combine any of the rest of it, so I just bring it down. Plus 35k plus 12. Now, one more example I forgot I needed to show you an example of this is, what if I have something that has an exponent? For example, 5 times 3y squared plus 4 plus 6y squared. So when we look at that, something really important to note is when I do the 5 times 3y squared, it's no different than having the exponent there than when we didn't have an exponent. Sometimes people get confused about that. So 5 times 3y squared is just 15y squared. That y squared part doesn't change. I just multiply the constant times the coefficient if the number on the outside is a constant. We haven't learned yet what to do if the number on the outside is a variable, or if what's on the outside is a variable. We're not going to do that, at least not yet. And then I do 5 times 4, which is 20, and it's addition because this is addition. And then I have plus 6y squared. When I combine like terms, I can combine 15y squared with 6y squared. And then the plus 20, that's the only term that's like that, so it's plus 20. So combining 15y squared plus 6y squared is 21y squared plus 20. Now, you have a couple of examples to try on your own, and you can see, go ahead and pause the video so that you can try these, and then you can check your answers in just a minute. And here are your answers.